Hello, hey, this is Dr. Tech, and this is a recording for my cisp440 class in fall 2018. This is about question number 2 of the final exam. So as you can see, this is a CNF question. So the first thing we need to do is to re-express psi, which is this part here. Into a CNF. So let's go ahead and get that started. I'm going to use the shorthand version. So we have not, wrong color here. And let's see, undo, there we go. Okay, so let's do again. So we have not R or not Q implies P. Okay, so we'll derive the CNF of this thing. So the first thing we need to do is to get rid of the implication. Okay, so we basically say this is the negation of not R or not P, not Q, and then the whole thing or the non-negative version of P. Okay, I think it just my palm touched the other exam, so that's why. And we can okay, I just have to be careful what I touch with my palm. Alright, so now we can go ahead and get rid of the negation on the outside of the disjunction. In other words, we're trying to take care of this negation first. Okay, and we're going to apply De Morgan's law, so it becomes the negation of R and the negation of Q, and then we do an or P here, and then we simplify that a little bit because double negation cancels out, so we get R and Q or P. This is not CNF because CNF is exactly the opposite of what we have here, because we have a DNF or disjunctive normal form. But to change this into CNF is easy. We just apply the distribution law where we multiply out all the terms. So it becomes P and R into one term. Oh, P or R. Okay, let me back up first. So P or R is one term, and then P or Q is the other term. So that's the CNF of psi. Okay, so if I want to be 100% clear here, then we look at the hypothesis. We look at the proposed theorem. The proposed theorem is this part here, and we have to first to negate it and then turn it into a CNF. So let's go ahead and negate it first. I keep touching the, let's minimize this so I cannot touch it again. And we'll also touch this thing and minimize that. Okay, there we go. So now we start with this one, and then we start with the negation of phi 0, phi naught. So it becomes really just the negation of what we see here. Q implies R or not R and Q and P. And by the way, the letters that you get, how P, Q, and R is arranged is kind of dependent on the version of the test that you get. As you can probably imagine, this is a permutation problem. We have P, Q, and R, and there are 6 permutations possible. So there's 6 versions of this particular test. All right, so now we look at this and go like, how do we get rid of the negation on the outside? Oh, by the way, we need another pair of parentheses like that. Okay, And because the negation is applied to the disjunction, we first have to use De Morgan's law to get rid of that. So now we get Q implies R, and and the negation of that, and the negation of not R, and again we're using the short form, not R Q P. Okay, and then we can get rid of, let's try to do two things at the same time. The first one is to get rid of the implication, so we have not Q or R here, and then the second one is to get rid of the negation of on the outside of the conjunction. So in this case we apply De Morgan's law, so we have not R or not Q or not P, like that. And then we get on to the second line. The first one has a negation on the outside of a or, so we'll apply De Morgan's law, so it becomes not Q and not R. The second term is kind of okay the way it is. I'm just simplifying the double negation of R to just R itself, or not Q or not P, like that. And we are actually pretty much done if you think about it, because the first term, it basically becomes Q by itself because of double negation. The second term is the negation of R, and then the last term is R or the negation of Q or the negation of P. So now we have the negation of the proposed theorem, and what we need to do now is to combine all of these and see whether we can arrive either at a conclusion that there's a contradiction because there's a zero from resolution, or we can basically exhaust all possible ways to resolve and it doesn't get to a contradiction. But before we go any further, I'm just going to double check my answer here and see whether I make a mistake or not. It's always good to double check to make sure. Okay. Alright, so this is okay. Let me see if I can use a tool. Let's see. The hand tool works really well because I just want to show you, where I'm pointing. So we want to double check that this is derived into that over here. Okay. So we start with not R or not Q implies P. We negate the first part, so it becomes the negation of not R or not Q, and then we use an or with the second part. And then we apply De Morgan's law. We put the negation into the inside, and then we change the or operator to an and. So we end up with double negation of R and double negation of Q, and then the or P doesn't get affected here. Double negation cancels out, so we have R cubed left, R and Q, or P, and then we use distribution so that it becomes P or R and P or Q, like that. So that seems to work okay. And then we look at phi 0, which is Q implies R or not R and P and Q. Okay. So the negation of that, we just put a big negation on the outside of the entire OR operation. So we end up with we end up using De Morgan's law. So we put the negation on the first part and a negation of the second part here. Then we turn the implication into a not the first part or the second part, and then the second conjunction, we apply De Morgan's law to it. So we distribute the outside negation to the inside. So now we have not R or not Q or not P. And then from here, we apply this negation using De Morgan's law to inside the disjunction. So it becomes double negation Q and not R, The second part doesn't get changed. And then from here, we just get rid of the double negation, get rid of the parentheses here. So now we have Q as one term in the CNF, not R as one term in the CNF, R or not Q or not P as another term in the CNF. So everything seemed to be fine unless I missed something that's really obvious, which is entirely possible. So now we look at the entire thing before we apply resolution. So we copy everything here. So we got P or R, we got P or Q, and then we got Q by itself, we got not R by itself, and then we got R or not Q or not P. Okay, so this becomes the long CNF, to apply resolution to. It looks like we got a lot of stuff that we can apply. So we'll start with this. Okay, we'll start with this not R and this R and resolve that. Okay, so I'm gonna use this notation so it's easier to actually see. So we have these two resolving to not Q or not P. Okay, now at this point I know it is very tempting to look at this term here and say, oh, it is the opposite of this. These two, P or Q, is the opposite of not Q or not P. That is not the case. Okay, these two cannot resolve because resolution only works on one term at a time. So we're gonna have to resolve one term at a time, which is fine. We got plenty of chances to do that. Okay, so we will apply. Okay, I'm just looking at the quickest route to do this. Okay, so let's go ahead and apply Q first. Okay, so we are eliminating terms individually. So we look at, let me use a red color here. We look at this Q, and then we look at this not Q here, and then we resolve that. Okay, so let's see what happens when we resolve those two. So on one term, we have P no, that's not going to work. I'll show you why it's not going to work. We have P left from this P here, and then the other side has not P left. But that's really just true, which is not very helpful. Okay, never mind, doesn't work. So if that doesn't work, we'll try these two. Okay, so we'll try this Q with this Q here, and then see how these two resolve. This Q is all gone, and so we end up with just not P left. Okay, now that we have not P left, we will resolve not P with one of these two here. Oh, okay, I see how this is going to work. So this time I'll look at this P, and we'll look at, okay, touch on something else yet here. Okay, I see, I'm touching the bottom of the screen. Okay, there we go. So this P and that not P is going to resolve, so we end up with a R left. Okay, so I'm gonna take this guy and take this guy here. So the P and the not P are going to cancel out, and we end up with just R left by itself. And of course, now at this point we can look at this term here, which is not R by itself. We look at this term, which is R by itself, and combine these two. Okay, so we have another resolution here. Okay, and that gives us contradiction. Okay, so we have a contradiction here. We're not done yet. Okay, if someone just get to this part, I would not call it done because there's no conclusion. So the conclusion is since psi and not phi 0 resolves to false. Okay. Back. Okay. Phi 0 is a theorem. All right, so that's the proof of, that's the answer of question number 2. So the way I'm going to grade this one is based on a few things, because we have to first convert. So I'm going to use a green color here. Okay, so we're going to look at this part here. Okay, which basically what I'll be looking at is, is the conversion to CNF successful with psi itself. Okay. The second thing I'm going to look for is the importance of the negation of phi 0 or phi naught, because we don't want to convert phi naught itself into CNF. We want to look at the negation of phi naught and turn that into a CNF. And as a result, this is what I'll be looking at, is the derivation of the CNF of the negation of phi naught. And then the fourth thing collectively that I'll be looking for is going to be the resolution of the CNF that combines psi and phi naught, not the negation of phi naught. There might be a faster path, to get to the resolution. I'm not exactly sure, how we can do that. Let's see here. Actually, there's a pretty quick way. But anyway, it's done is fine. As long as I can see resolution is done, and it gets to the answer of a contradiction. Okay, and then the last thing I'll be looking for is going to be the conclusion, because just because we arrive at a contradiction doesn't tell me anything. So I need to understand, what does that mean? So you have to tell me that when psi and not phi naught resolve to false, then the theorem phi naught is a theorem. Okay, the proposed theorem is actually a theorem. So that's it. Okay, so I'm going to stop the recording now, and when I have time to do any other recording, I will post that online too.